Good day, student. My name is Cyril, and today we'll be looking at WAEC Physics Practical Alternative B past question for June 18 that might likely come out in your exam. So at this moment, get your writing materials and your calculator, and we'll be right back. Welcome back, and let's get on with the question. The first section here is mechanics, and our first question says, a ball is thrown vertically upward with a velocity of 20 meters per second. Calculate the maximum height reached. And when you see a physics question, the first thing you do is to bring out the parameters. And if you look at this, our first parameter here is our initial velocity, which was given as u is 20 meters per second. And then they said calculate the maximum height reached. So our height is unknown. And from the question, they said that the ball was thrown vertically upward. So automatically you know that gravity is involved. And because it is thrown vertically upward, this is negative gravity as it is moving against gravity. So our gravitation, acceleration to gravity is 9.8 meters per second. So if you look at this question, we're going to use our equation of motion to solve the question. So if you look at this, you can tell that V is 0 meters per second. And the reason why V is 0 meters per second is because the ball is thrown upward and it's going to get to maximum height. So at that point, it has come to rest. So when the body comes to rest, the final velocity is always what? 0. So from this, you can tell that our formula will be V squared is equals to U squared minus 2GH. The reason why it is minus here is because of what? Our negative acceleration due to gravity. So from this, if you impute our values, it means we'll be having 0 squared is equals to 20 squared minus 2 times 9.8 times our height, which is unknown. So from this, you can tell that I have 0 is equals to 400. So 2 times 9.8 here will give me 19.6 height. So if I move this to the other side, I'm going to have 19.6 height to be equals to 400. So I divide both sides by 19.6 divided by 19.6. Our height will be equal to that will give me 20.4 meters. Moving on to question number 3, it says define moment of a force. The moment of a force is the turning effect of a force. The turning effect of a force. Question number 4, moving on to question number 4, it says a uniform meter rule is balanced at 45 centimeters with a 50-gram mass at 10 centimeters. Find the weight of the meter rule. So if you want to find the weight of the meter rule, first you have to know how to draw the diagram, because anytime you are dealing with equilibrium of forces, you must know how to draw the diagram in order to be able to tackle the question. So from the question, they said the uniform meter rule, when it said a meter rule is uniform, automatically means that the meter rule is 100 centimeters. And because this was balanced at 45 centimeters, it means I'm going to put my pivot at 45 centimeters. So this point here is 45. Then they said a weight or a mass of 50 grams was placed at the 10 centimeter mark. So I'm going to put a mass of 50 grams at the 10 centimeter mark. And then they said find the weight of the meter rule. If you have to find the weight or mass of the meter rule, the first you have to take into consideration is the center of gravity. The center of gravity of any uniform meter rule is at the midpoint, which is at 50 centimeters. So it means our center of gravity is going to be here. So the mass of the meter rule or weight of the meter rule will be here. So if from here down to this place is 50, and we know that from here down to this pivot is 45, automatically means that this place here is 5 centimeters. And if from here down to this place is 45, and from here down to this point here is 10, automatically means that this place is 35 centimeters. So at this point, we're going to take our moments about these forces. So we're going to take our moment to the pivot, take our moment to the pivot. So at this point, you're going to bring out our formula that we're using. So if you look at this, we have a formula that says that clockwise moment is equals to anti-clockwise moment. Clockwise moment is equals to anti-clockwise moment. And from Formula for moment, we know that the moment of a force is the weight times the distance between the force and the pivot. So in this case, what we have here is for our clockwise moment, we have this direction, and anti-clockwise moment, we have this direction. So we have our weight times 5 is equal to 50 times 35. So if you multiply this, you have 5 of the weight is equal to so I divide both sides by 5 divided by 5. So my weight is 350 grams. So this is the weight of the meter rule. Okay, moving on to question number 5. It says state 2 factors affecting the period of a simple pendulum. One of the factors that affect the period of a simple pendulum is the length of the cord or thread that you're using. Then we also have the mass of the pendulum, and then we also have acceleration to gravity. Then we also have air resistance. Moving on to question number 6. It says a body is acted upon by 2 forces, 4 Newton and 3 Newton at right angles. Find the resultant force. So the first thing you have to do here is to draw the diagram. So we have a force and we have another force. The first force here is 4 Newton, and then we have another force of 3 Newton. And from the question, they said they are at right angles to each other. So I have a right angle, and we have to find the resultant force. So I draw my resultant. So this is my resultant force. So looking at this, you can tell that this is a right angle triangle. And according to the rule of right angle triangle, when you're finding the sides of a right angle triangle, you apply Pythagoras theorem. So if we are using Pythagoras theorem, so we know that resultant square is equals to 4 square plus 3 square. So it means my resultant square is equals to 16 plus 9. It means my resultant square is equals to 25. So if I take the square root of both sides, it means that my resultant is equals to 5 Newton. Okay, moving on to question number 7. It says define density. Density is the mass per unit volume of a body, and you can see density is equal to mass over volume. Hence the unit is kilogram per centimeter cube. Moving on to the next question, question number 8. It says a solid weighs 1.2 Newton in air and 0.8 Newton in water. Find its relative density. So we have the weight in air, to be 1.2 Newton. Then we have weight in water to be 0.8 Newton. So if we are to find the relative density, our relative density is equal to weight in air minus weight of liquid over weight in air minus weight in water. But in this case, we don't have any liquid that is submerged into, so automatically it means we do not have weight in liquid. So with this, we know that our relative density is equal to 1.2 over 1.2 minus 0.8, and that will give me 1.2 over 0.4, and that will give me 3. So moving on to question number 9, says define equilibrium. Equilibrium is simply a state where the total sum of forces acting on the body is equivalent to 0. So when the sum of force acting on the body is 0, then you say that that body is in a state of equilibrium. Moving on to question number 10, it says a block of mass 5 kg slides down a plane inclined at 30 degrees without friction. find acceleration. So if you draw a diagram, you realize that this is your plane and you have a body sliding downward and the plane is inclined at 30 degrees. So whenever a body is sliding downward, it is moving in this format. So with this, you know that from your coefficient of friction, we know that your frictional force is equals to mg sine theta. And we also know that frictional force or force generally is also equals to mass times acceleration. So if you equate these two formulas, you can tell that your mass times acceleration is equals to mg sine theta. So mass here will cancel out mass, so I will have my acceleration is equals to g sine theta. And from that, we know from the question that we are given, they gave us the mass as 5 kg. Then they gave us the angle of inclination to be 30 degrees. And we are asked to find the acceleration, which we do not know. So this will have this formula that says that our acceleration is g sine theta. And we know that g is 9.8 meter per second squared. So automatically it means that my acceleration is equal to 9.8 times sine 30. And this will give me that my acceleration is equal to 9.8 times 1 over 2. Because sine 30 is 1 over 2. And that will give me that my acceleration is 4.9 meter per second squared. Moving on to the next question, we have calculate. Question number 11 says calculate the power of a machine that does 600 joules of work in 10 seconds. So our parameters here were given that we have to calculate the power. We do not know. We are given the work done by the machine as 600 joules, and then the time given for this work to be done is 10 seconds. And we know that the power in a machine that does work is work done over time. So automatically we know that the power is equals to 600 divided by 10, and that will give me that the power is 60 watts. Moving on to question number 12. It says a 5 kg object is acted upon by 20 Newton force. Find its acceleration. So in this question, we are given the mass of the object as 5 kg. And then we are given the force acting on it as 20 Newton. We are asked to find the acceleration. So from Newton's second law of motion, you can tell that force is equals to mass times acceleration. And that means that my acceleration is equals to force divided by mass. So automatically my acceleration here is going to give me 20 divided by 5. It means that my acceleration is 4 meter per second squared. So the next question is question number 13. It says define pressure and give its unit. Pressure can simply be defined as the force per unit area of a body. The force per unit area of a body. That is to say that pressure is equals to force over area. Force over area. As you can see here, force over area. And that is why the units of pressure can simply be Newton per meter square. Newton per meter square. You can also see other units of pressure like torr. You can also see Pascal. You can also see atmosphere. You can also see bar. All of these are all units of pressure. And so moving on to the next question. Question number 14 says a force of 200 Newton is applied on an area of 0.01 meter square. Find the pressure. So in this question, we are given the force as 200 Newton, and we are given the area as 0.01 meters square. So we are asked to find the pressure. So the pressure here is unknown. And we know that pressure is equal to what? Force over area. And since our force and our area has been given, automatically means that my pressure is equal to 200 divided by, so if you convert this 0.01 to be in fraction so that our calculations will be a lot easier, this will give me 1 over 100. So it means that my pressure is equal to 200 times 100 over 1. It means that my pressure is equal to 20,000 Newton per meter square. Moving on to the next question. We have explained how to determine the center of gravity of an irregular lamina. So when we're talking about an irregular lamina, is equivalent to saying an irregular object. Anytime you have an irregular object, the center of gravity can be determined by suspending the object on two sides and then tracing the verticals. Suspend the object on two sides and trace the verticals. Moving on to the next question, which is question number 16, it says, a spring extends 0.05 meters when a 10 Newton force is applied. Calculate the spring constant. So in this question, we are given the extension E as 0.05 meters, and we're given the force acting on it as 10 Newton. And we know from Hooke's law that force is equal to Ke. So automatically, this means that my K is equal to force over extension. So it means that my constant K is equal to 10 divided by 0.05, which is same as saying that K is equal to 10 divided by 5 over 100, which means that I have 10 times 100 over 5. 5 here 1, 5 here 2, it means that I have 200 as my force constant in Newton per meter. Newton per meter. Moving on to the next question. Question number 17 says, define work done. Someone might say that work is said to be done when energy is expended, but that is not all. Work can also be defined as the product of force and displacement, and it takes place in the direction of the force applied. That is to say that work done is equal to force times displacement, and it takes place in the direction of the force. So moving on to the next question, which is question number 18. It says a force of 15 Newton moves a body through 2 meters. Find the work done. So in question number 18, I have my force given as 15 Newton and it moves it through a distance of 2 meters. We have to find the work done. Work done is unknown. So we know that our work done is equal to force times distance, which means that my work done here is 15 times 2, and that will give me 30 joules. Question number 19. It says define impulse. Impulse can simply be defined as change in momentum. Change in momentum. Your impulse I is equals to change in momentum, which is mv minus mu. Moving on to the next question, question number 20, it says a 2 kg body moving at 3 meters per second is stopped by a force in 2 seconds. Find the magnitude of the force. So in question number 20, I have a mass of 2 kg and I have my velocity here as 3 meters per second, and then it said it is stopped by a force in 2 seconds. So my time here is 2 seconds. We have to find the magnitude of the force. So the force here is unknown. So with this question, looking at this, you know that our force is equal to mv minus u over t from our formula on Newton's second law of motion. So this is the same as saying that my force here is mv over t. as this is also equals to final velocity. So this means that my F is equals to 2 times 3 divided by 2, which means that my force here is 3 Newton. Okay, moving on to section B, where we have heat, light, and waves. The first question here is define specific heat capacity. Define specific heat capacity. Specific heat capacity can be defined as the quantity of heat required to raise the temperature of a unit mass of a body by 1 Kelvin. The quantity of heat required to raise the temperature of a unit mass of a body by 1 Kelvin. That is to say that your quantity of heat is equal to the mass times the specific capacity times your change in temperature. That is the formula for calculating specific heat capacity. Moving on to question number 22, it says a 1 kg block is heated from 20 degrees Celsius to 60 degrees Celsius using 16,800 joules. Find the specific heat capacity. So in this question, we are given that the mass of the block is 1 kg. We are given the initial temperature, theta 1, as 20 degrees Celsius. We are given theta 2 at 60 degrees Celsius, and we are given the quantity of heat as 16,800 joules. And the question says find the specific heat capacity, which we do not know. And we know that our formula says that Q is equals to MC theta 2 minus theta 1. So, and we have been given the quantity of heat, so we just impute our quantity of heat, which is 16,800 joules, to be equal to the mass there is 1 times the specific capacity, which we do not know, times our change in temperature here is 60 minus 20. So that will give me 16,800 is equal to C times 40. So I divide both sides by 40, divided by 40. So this means that my C will be equals to 42 joules per kilogram per Celsius. We can also say joules per kilogram per Kelvin. Moving on to the next question, that's question number 23. So define latent heat of fusion. Latent heat of fusion. Latent heat of fusion can be defined as the quantity of heat required to melt a solid completely to liquid without a change in temperature. Moving on to the next question, question number 24, is to define thermal expansion. Thermal expansion is simply increase in size, which could be increase in length, area, or volume as a result of increase in temperature. Moving on to the next question, which is question number 25, it says a ray strikes a plane mirror at 30 degrees. Find the angle of reflection. A ray strikes a plane mirror at the angle of 30 degrees. Find the angle of reflection. So if I have my plane mirror and I have my normal and I have my incidence ray coming this way and strikes it at an angle of 30 degrees and it is reflected from it, my angle of reflection is always equal to my angle of incidence according to the first law of reflection. So automatically my angle of reflection is 30 degrees. Moving on to the next question, question number 26, it says state Snell's law. Snell's law of refraction states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. That is to say that your constant, which is your refractive index, is sine of angle of incidence over sine of angle of refraction. Moving on to the next question, it says, question number 27 says, define real and virtual image. Real image are images that can be projected, and virtual images are images that cannot be projected. Moving on to the next question, which is question number 28. It says, A lens forms a real image of 10 centimeters from its center. Object is at 15 centimeters. Find the focal length. If you remember our mirror formula that says 1 over focal length is equals to 1 over image distance plus 1 over object distance. So in this question, we are given that the image distance is 10 centimeters and we're given the object distance u as 15 centimeters. We are asked to find the focal length. And since this is our formula, this formula can be rewritten as saying that the f, which is your focal length, is equals to image distance times object distance over image distance plus object distance. This means that my focal length f is equal to 10 times 15 over 10 plus 15, and that will give me 150 divided by 25, and that will give me 6. Moving on to the next question, question number 29 says, name 2 uses of convex lenses. Convex lenses can be used in magnifiers and can also be used in correcting hypermyopia. Moving on to the next question, question number 30 says, what is the speed of sound in air at room temperature? At room temperature, the speed of sound in air is 340 meters per second. Moving on to question number 31, says define critical angle. The critical angle in a denser medium given 90 degrees in the denser medium. Critical angle gives 90 degrees in a denser medium. Moving on to question number 32, it says define total internal reflection. This is the complete reflection of angles in a medium when the angle exceeds critical angle. Moving on to question number 33, state 2 applications of total internal reflection. Total internal reflections can be applied in optical fibers and in periscope. Moving on to the next question, question number 34, it says what is refraction? Refraction is simply the bending of light when it passes from one medium to another. Moving on to question number 35, it says that a ray passes from air with a refractive index of 1 to glass refractive index of 1.5 at 30 degrees. Find the angle of refraction. So we're given the refractive index of air as 1 and the refractive index of glass as 1.5, and they gave us the angle of incidence as 30 degrees, and we know that the refractive index of air times sine of the angle of incidence is equal to the refractive index of glass times sine of the angle of refraction. Since our angle of refraction is unknown, so this means that I have 1 times sine 30 is equals to 1.5 times sine of the angle of refraction. So this will give me 1 times 1 over 2 is equals to 1.5 times sine of the refraction. So this will give me 0.5 divided by 1.5 is equals to sine of the refraction. So that will give me 0.5 divided by 1.5. That will give me 0.333. So I will take the arc sine. So that will give me sine inverse of 0.333. So that will give me that the angle of refraction is equals to 19.4 degrees. Come to the end of today's session. Thank you for joining us. And if you have any question, drop it in the comment section. And if you want to get more videos like this, subscribe to our YouTube channel and turn on the notification bell to be notified when we drop a new video. Thank you.